one small step for man, one giant leap for mankind.
To safely return to Earth from space, a thermal protection system is required to protect astronauts from the searing heat of hypersonic flow around a space vehicle. In the days of Apollo, the heat shield was handmade cell by cell. When NASA developed the space shuttle, an entirely new design for its thermal protection system was needed that could withstand multiple entries through the atmosphere. Building on expertise developed during the Apollo era, NASA Ames Research Center at Moffett Field, California, developed and tested the new heat shield system for the shuttle. Today, several highly advanced heat shield solutions are in use as a result of that innovation. The Mars Science Laboratory relied on a material invented at NASA Ames called phenolic impregnated carbon ablator, or PICA, to protect it during its entry through the Martian atmosphere. PICA first proved itself to be highly effective when the Stardust mission returned to Earth in January 2006. Stardust set the record for the fastest entry of a man-made object on its successful return from deep space. Every NASA mission has unique requirements, and new heat shield technologies often need to be developed for each. Plans for future missions will demand even more effective heat shield solutions that exceed the capabilities of current technologies. NASA is investing in the future with innovative and game-changing approaches to making thermal protection systems. Technologists from NASA Ames Research Center, supported by engineers from NASA's Johnson Space Center, Langley Research Center, and Glenn Research Center, are leading the effort in new ways of making thermal protection systems. NASA is partnering with commercial textile producers and developing advanced automated weaving techniques to tailor and optimize performance. Weaving allows NASA engineers to manufacture both rigid and flexible materials that can withstand extreme heating conditions. Partnering creates an opportunity for best practices to be utilized that are sustainable, rapid, and cost-effective. To test new materials, special ArcJet facilities are utilized at NASA Ames and at the U.S. Air Force Arnold Engineering Development Center in Tullahoma, Tennessee. Engineers use the ArcJet to simulate the high-speed flow of atmospheric entry and test the thermal protection system at highly energetic conditions.
18 months ago, this was just an idea, woven thermal protection system, weaving a heat shield, and at this point we're already now in the stage of development where we're readying it for possible insertion into future human missions.
Using the woven technique, we're working to make a large heat shield that will allow safe return to Earth from a variety of NASA missions. Since weaving is an automated process, we can leverage that technique to design our TPS and have our TPS lightweight, robust, and inexpensive.
As an engineer, it's really great to work on technologies that are going to change the way of the future. NASA today is investing in innovation. And NASA's Space Technologies Game-Changing Development Program, it's helping to make future missions a reality.